Okay, let's take a look at the answers to moles sheet number 1. In our top section, we're going to be taking a look at how to calculate molar mass. So, the molar mass is the mass of 1 mole of a substance. We represent that in grams, or grams per mole. And we just have to add up the atomic masses of each atom in the formula. Let's try this out with our first example, calcium sulfate. To look up the atomic masses, we have to look at the periodic table. Let's start by taking a look for calcium. And so the atomic mass for calcium is 40.078. And so here's the full calculation. So calcium is at the top here with 40.078. Then we add in sulfur, 32.066. In the formula, there's 4 oxygens, so we have 4 times 15.999. And then we get the grand total of 136.14. The units that you want to use for molar mass are grams per mole. Okay, here are the answers for 2 through 4. Probably a good idea to pause the video right now so you can go through and check your answers. Alright, one of the things to watch out for, we see here in problem number 3, we have to make sure that we have the right amount for every single atom that we're working with. You can see here in example number 3 that with aluminum nitrate, there are 3 nitrates, and so what you want to do is you want to multiply that subscript on the outside 3 and distribute that with the subscripts on the inside, so you have 3 nitrogens, and 3 times 3 will be 9 oxygens. In problem number 5, we're going to be taking a look at how to convert from grams into moles. We have 361.88 grams of barium phosphide, and we already know the molar mass, which we're going to need. And so here's our molar mass we found out in problem number 3. No, this is problem number 2. Alright. Okay, so in both your textbook and also the video that you saw before in class, they were using a method called dimensional analysis in order to solve these problems. I'm going to show you a different way to do this. It's just using proportions. First, we set up the problem ratio. It's just the unknown, the thing that you're trying to find, in this case moles. So we have X moles, and that's over the given information. And you can see right from the problem that it's 361.88 grams. On the right-hand side, we have the target ratio, and that comes from your molar mass. So you see on the top, we have 1 mole over 473.929 grams. That was the number that we found in problem number 2. One of the important things about setting up a proportion is that you want to make sure that you have the problem ratio representing your known and unknown on one side, and you want to have your target ratio on the other side, have them distinct. Also make sure that the units are in the same locations, and so we have moles in the top on the left, so we have moles in the top on the right, and then grams on the bottom, grams on the bottom. To finish off this problem, we're going to cross multiply and divide. And so we'll just have a little cross here. And so here's the problem finished off. We just have to set the 2 diagonals equal to each other. And then we're going to divide by 473.929 on both sides, giving us an answer that's about 3/4. And when we do these kind of problems, what you can do is you can always be able to estimate your answer before you get going. And that way, if you come out with a weird answer, you'll know that something went wrong. Take a back look at the top here. We have 361.88 grams. We know that 1 mole was 473. And so it looks like you have about 3/4 of a mole. And we got an answer that's about 3/4 of a mole. So that looks pretty reasonable. Okay, here are the answers to 6 and 7. Might be a good idea to pause the video so you can take a look at these answers. In this next set of problems, we're converting from moles into grams, but that doesn't really change very much when you're working with your proportions. You can see here in problem number 8 that we start off with the unknown. In this case, it's grams. We put that over the given, 1.36 moles. And on the other side, we have the molar mass, but in this time we have grams over moles just to match the units in the same spots. Again, this might be a good time to pause this so you can copy down the rest of the answers and make sure that you've checked everything, that it's all correct. In problems 11 and 12, we are trying to find out the number of molecules or the number of atoms. So in other words, the number of individual particles. Since we're working with individual particles, we're no longer dealing with mass, so we won't need molar mass for this one. Instead, we're going to use Avogadro's number. So here's Avogadro's number. Each mole is worth 6.02 times 10 to the 23rd particles, and those particles could be things like atoms or molecules. Okay, here are those two problems figured out. And what's nice about these is that overall pattern for proportions is always going to be the same. What you're going to have on the left-hand side is you're going to have your unknown on the top, your known on the bottom, and on the right-hand side you're going to have your target ratio. And in this case we're using Avogadro's number, which is 6.02 times 10 to the 23rd particles per mole. And we're going to have the particles on top just to be consistent, and moles are on the bottom just to be consistent as well. So you can just pause for a couple seconds here so you can make sure that you've checked your answers, and then we'll move on to problem number 13. Alright, problem number 13 is a crazy little problem because we're starting off with grams and we're trying to find our way to calculate molecules. And so there's no relationship directly between grams and molecules. Moles is a central converting unit in this unit, so what we're going to do is grams can be converted into moles, and then moles can be converted into molecules. So here's that overall strategy. We can go from grams to moles and then moles to molecules. We can do that in two steps using two different proportions. We can have one proportion just to go from grams to moles like we did above at the top of the page, and then continue on to go from moles to molecules. Or let's try to do this in just one proportion as we work this problem out below. So the way we start all these problems is we're going to start off by having our unknown over our known, and now we're going to have to set that equal to a target ratio. So let's start working on setting up the right side. We always start off with the given information, so let's work with the grams. And so the only target ratio that we know that uses grams is the molar mass one. And so you can see here that I have 1 mole over 18.0148 grams. But now we see that there's a problem. If you're going to match up units, grams and grams in the bottom works out fine, but we have molecules and moles in the top, and those are different. So what I need to do now is I need to replace my 1 mole with something that's equivalent to 1 mole, but it's expressed in units of molecules. So let's just make that quick little switch. So we replaced 1 mole with what it's equivalent to in molecules, and now both the units on the bottom, the grams, and the units on the top, molecules, match up perfectly. And so now we can finish off solving the problem. And there we go. So let's tackle our last set of problems. Okay, these are involving individual particles. You can see atoms and molecules listed here. So again, we're going to be using Avogadro's number, and so let's take a look at those proportions. Okay, and again, it's probably a good time to pause it so you can check your answers.